Today we're going to look at subplots in Altair, creating different images of the same data in the same plot, but it's factored, it's chopped up in different ways. So we import pandas Altair, and we're going to import the data module from Vega datasets to use the Iris data. I'm sick of Seattle. I can't deal with Seattle. So I've gone back to Iris, and besides, Iris is in some ways better for what we're going to do today. So previously we've seen that as well as the x and y parameters in the encode method, that we can add color to distinguish different types and that. But as well as color, we can also add row and column. And what this does is it breaks up the data according to the category that you assign to column or row. So here we're going to set column to species, and that's going to give us a plot of 3 columns, one with Setsoa, one with Versicolor, and the last with Virginica, the 3 iris the 3 iris species that Fisher found. We'll just set the height and width to 200 because that's just a little bit too big for the screen. Hit shift and enter, and there they are. So it's a nice way of visualizing the 3 species together and separately, if you understand me. Control V, we change column to row, and this gives us a vertical interpretation of the data. Now we're going to create 2 charts here. The first one, H, is going to be a histogram. We're going to create a histogram of I think it was we create a histogram of petal length, and we're just creating this so that we have a histogram. It's not going to be the world's prettiest histogram or anything like that, but we're going to create 2 plots and to see how we can plot them together. 2 separate plots, 2 separate canvases, say, onto the one plot. So this is how you set up a histogram. We saw this before, I think. I'm just having something funny happening with my keyboard there. For some reason, the combination of a single quotation mark and a C were coming up funny. I have no idea why. One of those days. Anyway, here's our histogram. It's not the world's prettiest histogram, but it'll do for what we have in mind. As well as a histogram, we're going to create a box plot of the same petal length data. We said earlier about how the histogram and box plots are related to each other, where histogram emphasizes centrality. The box plot emphasizes where the outliers are in a particular data set. So we'll just take a look at our box plot, and there it is. It's fine. And now we're going to combine the 2 of them. And they combine absurdly easily. That shouldn't be A, should it? It should be H. Okay. So H ampersand B is the same. It combines the plots vertically. H pipe B combines the plots horizontally, so they appear in columns. With the ampersand, they appear in rows. H plus B means that one is plotted on top of the other. Now there's a lack of color contrast there, so for one of the very rare occasions we have a parameter for mark bar and mark box plot. Those are color parameters. I'm going to set the histogram to light blue, the box plot to navy, and that way when we go for a combined plot or H plus B plot, hit shift and enter, and here we can see the box plot standing out against the histogram, and this is how we combine the 2 plots, how we superimpose one plot on another. Now there are three different ways to do this. So these are three different combinations, and there are two different ways of combining each. In that Altair h comma b is an equivalent method to h plus b. So when we compare them for equivalence, we find that the equivalence is true. Alt v concat h comma b is the same as h ampersand b. It's the different name for the same method. Now, why they're duplicated, I don't really know. It's probably a legacy thing as Altair was being created. Alt h concat is the same as h pipe b. So these different methods exist, and you use whichever one makes you feel most comfortable. Finally, we're going to look at repeat plots. Repeat plot is a very powerful plot indeed. So repeat plot is a lot like a scatter matrix that's native to pandas itself, in that we can take a row of data, iterate over it against another row of data, or the same row of data, same row column names, say, and plot them all against each other, put them all on the one plot, and see what the different relationships are over the in one single place. So it's a little bit complex, so we'll take it step by step. The first thing we're going to do is we're going to create a variable called data, and data is going to be a list of the numerical columns in iris, which is sepal length, sepal width, petal length, petal width. So that is all the column names except the last one, and we call toList on the column names. It must be an array. Just the columns themselves are an index object in pandas, and Altair will reject it. It must be an array that we're going to use. Anyway, so here we're setting up the chart as usual. Alt chart mark circling code, and just leave the x and y empty. For now, we're going to add properties, height and width 150, because it's going to be a big chart. There's going to be 4, so 4 times 4, 16. There's going to be 16 mini charts on this one particular plot. So our x is going to take an alt x value, y is going to take an alt y value. They're both going to take similar values, which is an alt repeat object. The x-axis we're going to alt repeat along row, and we set type to quantitative. You must set type to quantitative, or else it isn't going to work. It's the same thing in alt y, alt repeat with one exception. It's alt repeat again, but it's alt repeat column instead of alt repeat row. Type again must be quantitative. And then the last thing we have to fill in are row and column variables for repeat, and these are both data, the four element list that we created earlier. But the result is fantastic, so that you see this very rich scatter plot that shows how the different data combine. The diagonal is always going to be plotting against itself, so that's going to be redundant, but what are you going to do? You can't have everything. And there's just one last thing we'll do just to make it beautiful, and that is that we're going to add a color parameter to encode. I'm going to color it according to species just to make it more visually appealing, and there it is. Fascinating the way that the different data combine. It's very, very useful technique, and it's with this useful technique that I'll leave you on. Please don't forget to like, subscribe, or notify if you want the videos to continue. Live long and prosper.